Okay, so essentially we're going to find the value of the integral from 1 to 9 of this graphed function here. Okay, so we're looking for the integral from 1 to 9 of f of x dx, where the function is this figure in blue. So this is the connection between calculus and geometry, because the area under the curve is the same exact value of the integral from 1 to 9. So essentially what we're doing is we're looking for all of this space underneath the blue curve. Okay, specifically we're looking for the space from this dot right here, which is 1 on the x-axis, all the way to this dot right here, which is 9 on the x-axis, and all that area under it. Okay, so technically it's a calculus problem, but it's more geometry than calculus, because if you see, if I were to connect this up this way, you see I just created a rectangle below. All right, and that rectangle has a width of 3 and a length of 8, if you just count the boxes, right? 1, 2, 3, 4, 5, 6, 7, 8. So width of 3, length of 8. So the area for that is 3 times 8, right? Area is length times width. So 3 times 8, which equals to 24. All right, so the area of that rectangle below is 24. I can create a square by dropping a line down that way, and I can find out the area of that square, which is a 2 by 2 square. So 2 times 2 is 4. So the area of that square is 4. And then I have two triangles I got to find the area of. I have this little tiny triangle right here, and I have a big triangle right here. Let's do the big triangle first. You know the area for a triangle is equal to 1/2 base times height. So in this case, my base, 1, 2, 3, 4, 5 boxes in width, the base, and the height, 1, 2, 3, 4, 5, 6 boxes tall. So the area, I'll call this A1. The area for the triangle A1 is equal to 1/2 times 5 times 6. Well, 5 times 6 is 30. Half of that is 15. Got it. And I'll call this A2, which is the area of the triangle. Again, 1/2 base times height. In this case, my base is 1 and my height is 2. So this is 1/2 times 1 times 2. 1 times 2 is 2. Half of that is 1. So now I have all my areas of my pieces. I know this is 24. I know this is 4. I know A2 is 1, and I know A1 is 15. The value of the antiderivative is simply adding up all those values. 24 plus 4 plus 1 plus 15. Got it. Okay, so I grab my calculator. 24 plus 4 plus 1 plus 15, and I get 44. And that is the value of the antiderivative, or the integral from 1 to 9 of f of x dx. Simply the area under the curve. Take care.